All right, so today we are going to be, shockingly, factoring again, as that's what we've been doing for days and days and days. So I have not overstated the importance of being able to factor. So the title of today's lesson in the book is More Uses for Factors. In parentheses here, I put what we're really doing, which is solving quadratic inequalities that only have one variable. So you'll notice that the problem's just one variable. X is only, no y's in the actual problem itself. So we are going to look at two ways to solve these quadratic inequalities, graphically, which you can see right here, and then we're also going to look algebraically. In your homework, on your syllabus, it specifies to you which ones of the problems you are supposed to solve graphically and which ones you are supposed to solve algebraically. So please, please, please make sure that you follow what's on the syllabus. You're doing 11 through 17. 11 through 13 you're doing algebraically. And 14 through 16 you're going to do graphically. Number 17, don't forget to do it. It's part of the assignment. But on that one, I'm not specifying which method. You can choose whichever method you like best when you are solving that one. So when we are solving graphically, we're actually going to put in a variable that's not there, kind of, and we're going to be drawing a graph of y equals ax squared plus bx plus c. So in this case, in example 1a, we're going to be drawing the graph of x squared plus x minus 2. Now, in order to do that, we are going to have to find the zeros, the x-intercepts. So zeros and x-intercepts are synonyms. They mean the same thing. Also, those are the same thing as the solutions to the quadratic. So solutions, x-intercepts, zeros, we all do the same thing to get them, and that is, again, not shockingly, factor and solve. So that's how we're going to start these problems. I've already got everything on one side except the zero, so I temporarily substitute an equal sign in place of my less than sign so that I can solve by factoring. Guys, if you could just factor and then slap the inequality symbol in the answer, we would just do that. The reason why we don't do that is because it's not mathematically correct. You do not get the right answer. And the reason for that is that when we solved by factoring in yesterday's lesson, we talked about the zero product property. The zero product property says when a product is equal to zero, not when a product is less than zero or greater than zero. So trust me, if we could do this in a way that was less work, we would, but we can't. So we start off by substituting the equal sign temporarily, and then we're going to factor this. So continuing to go through your steps always when you factor. First, I look for a GCF, which since these are both a 1, I know there isn't one. Next, I look for special products. This is a minus 2, so my third term isn't positive, so I know it's not a special product. Next, I look to see if my leading coefficient is 1 or something else. In this case, it is 1, which tells me that this is the quick way of chart factoring. I'm looking for what multiplies to -2 and adds to +1, because when no coefficient is written here, it's understood to be a 1. So there are only two things that are going to multiply to give me -2. That's -2 and 1, and then +2, -1. These ones add to -1. These ones add to +1. So these are my winning numbers. Remember that when the leading coefficient is 1, the winning numbers go right into my factors. So this factors into x plus 2 times x minus 1. All right, so now I've got it factored. Then I do exactly what we did in lesson 7.3. Set each of my parentheses equal to 0. That's the zero product property. So x plus 2 equals 0, x minus 1 equals 0. So here I subtract 2 on both sides to solve. So x equals negative 2. Over here I add 1, and I get x equals 1. These are the solutions, which means they are also the zeros. Zeros, when we look at the graph, become the x-coordinates of the x-intercepts. So that means where x is negative 2, which is right here, and where x is 1, there's going to be an x-intercept. So I plot those. Now, don't die of shock. This is one of the only times I'm going to say this year. When we draw the graph here, we must plot the x-intercepts and then I'm going to allow you to just sketch the graph. This is one of the only times where the rest of the points I don't need you to plot exactly. The reason why is because the graph isn't our answer. It's just part of our work. We're just using it to get the solution. So you certainly could graph x squared plus x minus 2 in your graphing calculator to see the shape if you want, but you should know from Algebra 1 that when we have a quadratic, that its shape is a parabola, and also that if the number in front of the x squared is positive, that parabola opens up. If the number in front is negative, the parabola opens down. So again, what I'm saying here, you have to plot the x-intercepts exactly. But the rest of it you can just rough sketch. So I don't know that it comes down this far. It might only come down this far, but that doesn't really matter to us being able to get the answer. So we do a rough sketch there of the rest of it. Make sure on the ones that say solve graphically that you actually have the graph on your paper. That is a requirement. So once I have my rough sketch, I'm down to step 3. It says use the zeros to identify the x values for which the graph lies below the x-axis for less than or equal to inequalities, and x values for which the graph lies above the x-axis for greater than and greater than or equal to inequalities. So what I basically do after I've got my graph is I look back at my original inequality. My original symbol here is a less than. This tells me, because it's a less than symbol, that I want to identify the x values where the graph is below the x-axis. So the part of the graph that's below the x-axis is obviously here. I just always squiggle it. You can highlight it or do whatever you want. If this is what's below the x-axis, the x values that give me these points are the ones in here, in between these two x-intercepts. For instance, if x is negative 1, I'm going to get this point down here. If x is 0, I'm going to get this point. So the values between those two x-intercepts are the values that give me below the axis. Whenever we write between for x values, we write it as a sandwich. Because my original symbol was a less than, these are going to be less thans. And I then have my answer. That in order for this quadratic to be below the x-axis, meaning less than 0, the x values have to be between negative 2, this guy right here, and positive 1, that guy right there. All right, so now let's look at another one, another example of solving graphically. So, first thing I do, again, is take out my greater than or equal to and temporarily put in an equal sign. So equals 0 here. Now I'm going to solve by factoring. So I look for a GCF. I find quickly that there isn't one. I also know that this is not a special product because 3 does not have a perfect square root, neither does 2. So that means because my leading coefficient is not 1, over here my leading coefficient was 1, so it was easy chart factoring. Here it is not 1, so this is where you have to choose to do either guess and check, split the middle, or the box. Again, I do not care which way you choose to do it. I'm going to do this one with guess and check because these are small numbers, which means I shouldn't have a lot of possibilities. The only possibilities of things that multiply to 2 are 2 and 1. So one set there. For 3, notice that this middle term is negative. That means the factors that I'm listing for 3 should both be minus. So I only have one set of choices, -3 and -1. So when I set up my parentheses, again, I'm guessing and checking. I know it has to be 2x and x at the front. Now I just need to decide which way to put the -3 and the -1. I know they're both negative. I just have to decide whether the -3 goes here or whether it goes here. Again, once you try something, check it to see if it works. I know that the one that's going to work is this one because I need to get -7x in the middle. This is going to give me -6x. This then is going to give me -1, and -6 plus -1 is -7. So I've got it factored, which means now I'm going to solve. So set each factor equal to 0. And then get x alone. So here I'm going to add the 1. So 2x equals 1. Divide by 2. And I get x equals 1/2. Here, just a one-stepper, add 3. I get x equals 3. So I factored, I solved. Now I'm going to plot the x-intercepts and sketch my graph. So x equals 1/2 is right here. X equals 3 is right here. Because this is a positive quadratic, that means this one also opens up. So draw a sketch where the parabola opens up. Once you've drawn your sketch, then you look at your original inequality symbol. In this case, it was greater than or equal to. I find that here. I'm looking for the part of the graph that lies above the axis. So this is above the x-axis, and this is above the x-axis. Now, over here, the x values that gave me this part of the parabola were the ones between. Here, the x values between would give me this part again, and that's not what I want. The values that get me, say, this point right here is when x is 0. That is below the 1/2. So values equal to or below 1/2 will give me values over on this arrow. To get the values on this arrow, this one, for instance, would have an x value over here. Those are x values that are bigger than 3. And so these become my answer. Notice I used the equal sign because there was an equal sign on my original symbol. Notice how these two answers are set up like our answers were for absolute value inequalities, where we either had an or we had a sandwich. This is going to end up the same way. It's one or the other. You're not going to have anything other than these two situations. And to be more specific, if what you are coloring in, so what's above the axis or below the axis, is the loop of the parabola, then your answer is going to be a sandwich with the solutions. So my solutions were -2 and 1. I wrote a sandwich with those two. If the part that you're highlighting, squiggling, whatever you want to call it, are the arrows, then you're going to write an or with the solutions. So again, my solutions were the 3 and the 1/2. So less than or equal to 1/2, greater than or equal to 3. And that is our solving graphically. Now we're going to look at solving algebraically. So both of these could be solved graphically as well, but we're just going to make sure that you can do both. They start off the exact same way. Replace the symbol with an equal sign, and then we're going to factor and solve. It does tell you you could solve other ways. If you remember those ways and want to use them, have at it. All the ones in your homework should be factorable. There is no GCF here. It's not a special product because 6 doesn't have a perfect square root. The leading coefficient is 1, which tells me it's easy chart factoring. So I'm looking for what multiplies to 6 and adds to -5. So 1, -6 would multiply to 6, but those add to -7. So it should be -3, -2 that multiply to 6 and add to -5. So these are our winners, which means factorization is x minus 3 times x minus 2. Then I solve, so set each parenthesis equal to 0 and get the x's alone. X equals 3, x equals 2. So that's step 1. Step 2 tells you that these solutions are also called critical values. When we solve algebraically, we plot them on a number line instead of plotting them in the coordinate plane. Of course, you have to make sure you put them in the right order. 2 comes before 3 on the number line. Next, we test a point from each interval of the number line to see if it satisfies our original inequality. So that means I need to pick a point that is less than 2. So I'm going to pick 0. 0 is the easiest thing in the world to plug in. So if I plug in 0 here, 0 squared is 0. 5 times 0 is 0. And then my 6. I end up with 0 minus 0 plus 6, which is 6, greater than 0. You are looking to see if this is a true or a false statement. If it is a true statement, then either put a check or write yes on this interval. That means these x values should be solutions. Then I pick something from the next interval. So since these are both integers, I'm going to have to pick a fraction or a decimal. This is just our work, so you're allowed to use a decimal. So I'm going to pick 2.5 just because it's smack dab in between. You probably want to use your calculator. I bet that most of you can't square 2.5 or multiply it times 5 just in your head, and that's fine. Use your calculator to help you. So if I go to type this in on my graphing calculator, I'm doing 2.5 squared, so why is it not punching anything? Okay, sorry, had to restart it. It was not working. So 2.5 squared, because it says x squared, minus 5 times 2.5 plus 6 is what I'm doing there. So my calculator tells me that's negative 0.25. So I get negative 0.25 on the left side. 0, of course, is on the right. Negative 0.25, negative 1/4, is not greater than 0. So this is a no. Now I try something in this interval, which means I need to pick something that is bigger than 3. So I'm going to pick 4 just because it's the next number. So that one you should be able to do without a calculator. 4 squared is 16. Negative 5 times 4 is negative 20. And then I've got my plus 6. So 16 minus 20 is negative 4. Negative 4 plus 6 is 2. 2 is indeed greater than 0. When you look at this number line, you see I've got yes, no, yes. That means the values where x is less than 2 are solutions. So x less than 2, or x could also be greater than 3. So we get an or because we had the yes, no, yes. And again, the reason why I don't have equals on these is because my original symbol didn't have an equals. All right, last one. First thing I need to do on B is I need to get the 4 moved to the other side because I don't have it in standard form with the 0 on the right yet. So subtract 4 from both sides first, which gives us this. Then we go ahead and replace our inequality symbol with an equal sign. And then I'm going to solve by factoring. So same factoring steps over and over and over again. Hopefully you know them well enough to say them to yourself so that I'm not having to say them all the time. Look for a GCF. In this case, there is not one. I know this isn't a special product because this third term is negative. Because my leading coefficient is not 1, I know that it is not chart factoring here. I have to guess and check or do split the middle or the box. Again, I prefer guess and check because I think it's faster, especially when the numbers are small. So 3 and 1 here. For -4, it could be -4, +1. It could be +4, -1, or it could be 2 and -2. So when I factor then, open up my 2 parentheses. I know it's going to be 3x and x. Again, once you've done enough factoring, and if you understand the way FOIL works, you really shouldn't have to guess very much. Normally, I say it's the ones closer together that we would try first. In this case, I know that's not going to be right because I know in the middle I need to get 11. And I know that 3 times 4 is 12, whereas 3 times 2 is only 6. So I know I'm going to put the 4 here and the 1 here. It's just a matter of getting the right signs. I want my 11x to be positive, which means if I make my 4 positive and my 1 negative, now I have 12x minus x, which is 11x. So again, there's nothing wrong with having to guess and check, but I'm just pointing out to you how you can maybe have to guess fewer times. All right, so once I've got it factored, then I'm going to solve. So 3x minus 1 equals 0, and x plus 4 equals 0. Here I'm going to add the 1, and then divide by 3. So x equals 1/3. Here I'm going to subtract the 4. X equals -4. Then I draw my number line. Please make sure you put the numbers in the right order. -4 comes before 1/3 on the number line. And then I pick things in my intervals. So below -4, I'm going to pick -5. So again, you're welcome to use a calculator. If you have trouble doing something in your head, then use a calculator by all means. So -5 squared is 25 times 3 is 75. Then 11 times -5 is -55. And so I'm wanting to know if that's less than or equal to 4. So 75 minus 55 is 20. That is definitely not less than or equal to 4. Now I go to my next interval. I love 0. 0 is my favorite number to pick, and it's in this interval, so that's what I'm going to pick. So 0 squared times 3 is 0. 11 times 0 is 0. So there, very quickly, I end up with the statement 0 is less than or equal to 4, which is true. So this gets a yes. Bigger than 1/3. Just because this is a fraction doesn't mean you pick a fraction. Pick 1. It's bigger than 1/3. So 1 squared is 1 times 3 is 3. 11 times 1 is 11. And 3 plus 11 is 14, which is definitely not less than 4. Here my yes is only in the middle, which means that the values of x that will satisfy my inequality are those that are between -4 and 1/3. So I write myself a sandwich. This sandwich gets the equal signs because my original had the equal signs. All right, so we've done 2 examples of sandwiches, one graphically, one algebraically, 2 examples of the ors. one graphically, one algebraically. Remember that you can always come back and rewatch this video if you're having trouble, or even part of it. It is linked on the website. All right, so homework again, make sure you do all the way through 17, 11 through 13 algebraically, 14 through 16 graphically.